Now, members, let us see examples about flowcharts. Now, to determine, of course, we are going to see examples. I'm going to do them as I explained here. To determine the purpose of a flowchart, always analyze the items that you are printing. So, when they give you something and they tell you print this, to get a purpose, you always analyze those things you are printing. Okay, let us see an example here. Perform a dry run for x naught equaling to this, n is equal to this, and tau equaling to this on a flowchart and on a flowchart below. So the purpose of the flowchart. Now this is our flowchart. You see that now they are giving us tolerance to this, meaning you see that this one is a tolerance when n is equaling to 3 decimal places. So that's why we have it like this. It means that now in our flowchart we have to give our answers for the small places. Now, here is what they are telling us that we start with by putting in 0. We are going to read n, x naught, then the tolerance. Then this is the formula that we are going to use. Now this is the computation that they are telling us to use these values. Then is x minus xn minus plus 1 minus xn is there modulus less than the tolerance. Our total, remember our tolerance is given here. If no, you go and add a 1 to this, and if yes, you print xn plus 1 and then the n. Now, here the idea is, you know this is the number that we use to find roots of numbers in the numerical, in the Iterative formula and then methods. So now, that's what we are going to do here. So they are telling us that we start with when n is equal to 0. So what we are starting here with is what we put it in here. The things we are going to print are these. But to get this, you need xn. So when you do this, now this is what I'm going. When n is 0, I will have x naught equaling to 2. Why? Because it's the initial value. My n here is 65. That's why I'm going to put into this formula. So when n is 1, I'll get the next root as x plus 1. As you see here, when I put here, so I get this. Now this is what I have. Now, when I put it into this formula, I told you how to press them on the calculator. When you put this value, you put in this. This is x, this is x. Then this is 65. Then you press R. Then you press x. They will ask you which value of x. Then you press 2. When you press 2, this is the value you get. So now, after getting that value, we need to know. They are asking us, is x naught, is x1 minus x naught less than 12? Because now this is our xn. This is our xn plus 1. This is our xn. When you subtract them, is the error you are getting less than the tolerance. When you subtract this from this, we get 0.4125. That is the total we are getting. And the answer here is no. So if it's a no, then they are telling me that on n, now the new n you are going to use, you are going to add a 1 on the n. Then you substitute in this formula. So when we add it, this is our previous n. We add 1 on it, we get now 0 plus 1, we get 1. Means that now our n we are going to use is 1. So x1 now is going to be. Remember our x1. This is the value that we are going to use. So we bring it here, 2.4125. Now, when n is 1, I'm going to get this as x2. Then you press R, then you press this value in there. And when I press it, now we are going to 4 decimal places, it gets me to 2.3138. That's what I'm getting. And now, 38. When I subtract now, I need now to get the error. Get this minus this. What do we get when we subtract that? What we get here is 0.0987. Is it less than the tolerance? 0.07? The answer is no. If the answer is no, go back now on the previous n, you add a 1. So I'll be adding now here 2. Now when I put here 2, I'll be adding x2 equaling 2. Now, when I get x2, it's going to be now this previous value. We are going to use 2.3138. When I put here 2, I get now 2 plus 1, which would be 3. And then you press R, then you fill in this value. Now, this is our xn. In terms of xn, we are getting now this 2.3138. The answer I'm getting here is 2.3046. Multiply when you subtract this from this because we need the error. So this is our xn minus this. Then we take the absolute value. The value we are getting there is 0.0092. Is this less than 0.005? The answer is no. If it's no, the previous n, we add 1. When I add 1 here, I will get a 3. So now my n is 3. So I'm going to use x3 equaling 2. Now this is my x3, 2.3046. After doing that, now when n is 3 plus 1, I'll get now x4. This is my x4. Then I press R, then I put in my new root, 2.306. Press equals. What I'm getting here is 2.3045. What we get in the subtract? So you subtract this from this. You see, this will be 0.0001. Is it less than 0.005? The answer is yes. And now, if the answer is yes, then you print the value you have for xn plus 1 and the n. So now, xn plus 1 will be the value you have for xn. The last value, when we go to this value of is this 2.3045. Now, because our term was equal to 0.5 times 10 power negative 3, this means that decimal places. So meaning that now we give our answer also 3 decimal places. So there our xn plus 1 will be 2.3. 2.30, then we round off to this, we get 5 to 3 decimal places. What is our n? Printing our n is that our n is going to be the same because it's not changing, is 65. So this is what we have, and also this is what we do after printing. Now, they are asking us now, set the purpose of the flowchart. Set the purpose of the flowchart. Now we analyze this and this. You see that this formula here, I think remember in the Iterative method, these are formula for printing roots of numbers. So we want to know what root gave us this. So now we say 0 now 2.305 power k is equal to 265. What are we getting? Introduce natural log on both sides. It's okay. Natural log of 2.305 equal to natural log of 65. And so our k will be natural log of 65 divided by natural log of 2.305. And from there, it's that our k is going to be approximately 4.9, which is going to be 5. So it means that now, this 5, we are getting the kth root of this, meaning if k is 5, we are getting the 55th root. So from there, the purpose, allow me to write here, therefore the purpose was to print the if it's the root, if it's root of 65, as simple as that. So it's that when you get now our 2.305 equaling to 65 power 1 over k. I think I can write it here so that I can visit ABC. 2.305 equaling 65 power k. But remember our k is equal to 5. I think you can see. 2.305 will be equal to 65 power 1 over 5. That's where I'm getting the decision from. 2.305. So, as simple as that. So, that's how we handle this project. We are going to see more examples in the next lesson. Please don't forget to subscribe to the channel. See you there.